So here's part D of number 6 from the 2012 AB exam, and in this question they want us to find the position of the particle at time t equals 4. Well, what we have to work with here is we have velocity. Velocity is the rate of change of position. If we want to figure out how much position has changed from our starting value 0 to 4, what we're going to have to do is we're going to have to do this integral. The integral from 0 to 4 of the rate of change of position, which is represented by velocity. So we're going to have to do this integral, but this is just going to give us the change in position from 0 to 4. To find the actual position at 4, we're going to have to take into account where the object started at t equals 0, and that's at the x value of -2. So if we can find the value of this expression, we're going to have the position of the particle at time t equals 4. And again, that's the starting position plus the amount the position changes found by integrating its rate of change from 0 to 4. So let's focus on this integral. It does ask us to find this. This is going to be something that's not that easy to do. We are going to have to recognize that we have an inner function right here, and so what we're going to need to do is we're going to need to use a little u substitution. So don't want to rewrite the integral yet. I want to do a little u substitution with it. So if I let u equal the inner function, let u equal pi by 6 times t, my integral is going to, and I'm going to save this space here for the answer, so I'm just going to kind of work downward to compute the value of this integral. U is going to be equal to pi by 6 times t, so my integral is going to be able to be rewritten as cosine of u. I do want to change the variable of integration from t to u, so figure out what the relationship between du and dt is. So the derivative of u with respect to t is going to be just pi by 6. The derivative of a number times t is just the number. What does dt equal? Well, I'm going to multiply both sides by dt, and I'm going to multiply this side by 6 and divide that side by pi. So what I can put in place of my dt is I can put 6 pi times du, 6 over pi times du. So I'm going to have 6 over pi times du go here. I haven't written down my limits of integration yet, and this is a place where you can kind of go one of two directions. The best notation, the notation that the College Board wants you to use, is going to be to change these limits of integration from values of t to values of u. Whatever you see on these limits of integration are always assumed to be values of whatever variables within your differential. What we've kind of done most of the time, though, is we've actually left these numbers as values of the original variable. But when we do that, just to kind of remind ourselves that they are t values and not u values, we can just say t is equal to 0 and t is equal to 4. And all that means is we're going to have to back substitute this in place of u before we put anything in place of the t's. And that's definitely something that we do when we do an indefinite integral this way, so we've just used the same mindset when we've done definite integrals involving u substitution. This constant, 6 over pi, I can take out in front of the integral. The antiderivative of cosine of u is going to be positive sine of u. I would need to evaluate this from t equals 0 up to t equals 4 and take a difference. I do need to back substitute before I start putting anything in place of my variable here. So my function I'm needing to evaluate, or my antiderivative I'm needing to evaluate, is going to be sine of pi by 6 times t. And then we would just have to evaluate this at 4, evaluate it at 0, and take a difference. So if we are evaluating this at 4, that's going to be pi by 6 times the sine of, well, if I put a 4 right here, that's going to be 4 pi by 6. And that's going to simplify to 2 pi by 3. And then I'm going to have to subtract from that what I get when I evaluate the antiderivative at 0, and that would be sine of pi by 6 times 0, which is just 0. So if we use the unit circle, let's see, where do I want to do this? I guess I'll do it right here. So if we use the unit circle, sine of 0 is easy. Hopefully used it enough that you don't even have to rely on the unit circle for it, but just in case, you know, sine of 0, the angle 0 is there. Sine of 0 is going to be 0, since sine would correspond to the y-coordinate of any point on the unit circle. So this is essentially 0. That goes away. So the change in position from 0 to 4 is going to be 6 over pi times the sine of 2 pi by 3. Now we don't want to leave this trigonometric ratio unevaluated within our answer, so we do want to do a little bit of work to see if we can find the value of this. So pi by 3 would be equivalent to 60 degrees. 2 pi by 3 would mean I'm going 60 more degrees around the circle, or pi by 3 radians more around the unit circle. So sine of 2 pi by 3 is going to correspond to the y coordinate right here. There would be one of two ways that you can handle this. The first way you can handle it is if you remember your 30, 60, 90 ratios pretty well. You can use them to figure out what the y value is going to be right here. So I'm just going to draw myself a little triangle. You know, if this is 60 degrees or pi by 3 radians, pi by 3 more radians, I still have pi by 3 more radians or 60 more degrees to go to make it to this 180 degree measure or this pi radian measure. So this angle right here would correspond to 60 degrees or pi by 3 radians. And so what you can say is the hypotenuse or the radius of the unit circle, hypotenuse on that triangle is 1. And you can use your 30, 60, 90 ratios from there, since this would be equivalent to a 60 degree angle, that'd be a 30 degree angle. And you can use those ratios to figure out what this y value right here would be. The alternative to that would be to reflect this triangle into the first quadrant, and that would be your pi by 3 angle. And what you can do is you can use your left hand trick to try and figure out what the value of sine of pi by 3 is. So the value of sine of pi by 3, so if this is a bad attempt at drawing your left hand, this is your pinky finger, which is the positive x-axis. Your thumb is the positive y-axis. And then your other 3 fingers, ring finger, middle finger, index finger, are going to be the 3 important angles within the first quadrant. So that's going to be your pi by 6 angle, your pi by 4 angle, and your angle that you're supposed to be concerned with this time, that pi by 3 angle. If you pull your index finger in, the one that represents the angle pi by 3, if you get rid of that, since S comes after C in the alphabet, or since S is below C in the alphabet, we would count how many fingers remain below the one that we've pulled in, and that was the index finger, and that would be 3 fingers remaining below the one that we pull in. We put that number of fingers underneath a root, and we always divide that answer by 2. So this y value, or the sine of pi by 3, is going to be square root of 3 over 2. If we reflect this angle back over into the second quadrant, or reflect this triangle back over into the second quadrant, the y value stays the same. The y value is still the same distance above the x-axis as the one that's over here in the first quadrant. So the sine of 2 pi by 3 is going to be square root of 3 over 2. And then we'd have a 6 pi there. This is going to simplify a little bit more because we can divide this by 2, and we can divide that by 2. So we have 3 square root of 3 over pi as the total change in position from 0 to 4 for this object, or the value of this integral. So if we take negative 2 plus that, what do we say, 3 square root of 3 over pi, we have the position at t equals 4.